So today we'll work with APIs, okay? And we will learn several things. We will learn what is an API, how to use the functions provided in JavaScript to connect to APIs. So JavaScript functions for consuming APIs, in particular fetch, okay? And we will learn about promises and async-await. Okay, so let's start with APIs, and we will see all the other things in today's class. So APIs. So API is essentially the letter for application program interface. Now, API has there are several things that can be called an API, right? So it's basically because it's essentially an interface for a program, okay? So that means that, for example, the React library, okay? You've been learning React so far. But the React library has an API. That API is essentially all the functions in that library. For example, create context, use state, use context. All the functions in that library is what we call the API of that library, okay? Because it's the interface that we as a developers use to create applications using that library, in this case, React. The same way can be applied, the same concept can be applied, for example, to Next.js. You will be using Next.js, and Next.js is a framework, it's a React framework, okay? But again, the same way we have functions in React, we have conventions in Next.js, for example, the pages folder, right? The app folder, how your project is structured. All those are APIs, because when you apply those conventions and you run Next.js, Next.js knows how to interpret all those pages, all those components, and put it in, create your app, run the app for you, right? So that's also an API. And in another sense, we can also call an API when we have a server, right, with certain resources, and our application connects to that server using a protocol and makes requests, and we get responses from that, right? So that's also an API. So when you see the word API, it can be applied to many things. Today we will use it in the sense of connecting to a server and then consuming information or resources from that server, okay? And for the APIs that we will use the protocol HTTP. HTTP, of course, is the hypertext transfer protocol. That means that all of our APIs will work in a server-client relationship, okay? So there is always a server and there's always a client. Who's the client, who's the server? The client is essentially who's making the request, and the server is the one that's getting that request and is sending the response. And the interaction always starts with the client, okay? When you have this type of protocol, server-client, it's actually client-server. The interaction always starts in the client, okay? Because this protocol has its own limitations. The first limitation is the server doesn't know who's making the request, right? That's the first limitation. Okay, the server is just there in the internet waiting for requests. Anybody can make a request. That doesn't mean that the server will respond to anybody, but essentially the server doesn't know who's making the request. And the other thing is that this connection is stateless. Stateless means that once you make the request, the server completely forgets about who made the request, right? There is no way to connect to a server and keep that connection open, right? You make the request, the server responds, that's the end of the interaction, right? You can make 1,000 requests, but every request will be different. It will be isolated from the others, right? It's different from other protocols when you establish a connection with the server and that connection stays open, okay? And then you can send information to the server and the server can also send information to the client. That's different, that's a different protocol. In the HTTP protocol, you have a client that's making that request and you have a server sending the response. And the interaction always starts with the client and is basically stateless. Now, every request, okay, so at the end of the day, what we have are requests. Okay? Now, every request that we make have a certain set of parameters. So the server can identify what type of request this is and can answer to that request, okay? So these parameters are, first of all, the path. Let me make this the path or the URI. URI means universal resource identifier, and if it's not that, then let me know, but you can Google it. I think this is the way I know this. It's essentially what resource I'm trying to access in the backend, right? And we will see where is that encoded in that request. Now, we also have a verb. This is essentially what is the type of action that we want to perform. And these are pretty much standardized. And these are the possible ones: get, post, patch, put, and delete. Now, every verb or every type, so basically the verb is the type of request, right? Let me make a note here that this is the type of request. Usually it's known like the type of request. Now, the type of request in every one of these cases, get, post, patch, put, and delete, they have different meanings. Like, for example, get is essentially a query. It's just getting information from the server, right? So, querying information on the server. Okay, that's what a get request is. A get request never modifies data on the server. That means that you can make 1,000,000 get requests and the data on the server will stay the same, right? Because records in the database or in the server don't get affected by how many requests you make, and how many get requests you make. It's just querying data. I'm just looking at data, okay? That's what a get request is. Now, post requests usually have two uses. One is for creating new data or performing operations. When I say creating new data is when you have a form and that form is capturing some information and sending it to the server. You want to create some records out of that information. For example, when you are creating a transaction, let's say you open your bank application and you say, okay, I want to send this amount of money to this another account. All that information will essentially create new records in the server, or is performing an operation in the server. So that request is sent as a post request, okay? Patch, well, this is kind of obvious, right? It's modifying records. Like usually when you have, let's say you have your settings, or you have you have some type of information like record that you have, and you want to modify some parts of that record, you can say a patch request, and you only need to include. That's the nice thing about patch requests, is that you don't have to send the whole data. You can only set a subset of the data that you're changing. So that has the meaning of I'm just patching this object or this record with this new data, right? But I don't have to send, like in a post request, I don't have to send the whole data. I only send the subset of data that I'm changing. That's what a patch request is. So patching existing records. Put request is kind of similar. I will have to find the definition of what a put request is. I don't use it, to be honest, much. I think it's related to files. When you want to send file information, let's say you are uploading a file, usually associated with that, so when you're loading files. The thing is that you can also load files with posts sometimes, right? So usually for files, so uploading files, but please check in the official documentation what the put request is.
Sending a put request will update or replace existing data on the server. Post, on the other hand, is a safe method because it does not modify the state of the server.
Wait, what? Post?
It says put request will update or replace existing data on the server.
Okay, and post?
It says is a safe method because it does not modify the state of the server. Sending a post request will create new data on the server, but it will not modify an existing data.
Oh, okay, that's the semantic of it. So it's creating but not modifying. Yeah, remember that get doesn't modify, post doesn't modify, only creates, put modifies, never creates.
Okay.
So that's the semantic of the method. And of course delete, the word is pretty much self-describing. It's deleting data. Okay? So we have the resource that we want to access. We have the type of request that we want to send. There is also a payload. By the way, before the payload, we have a section called headers. This section is essentially metadata about the request. So this metadata about the request will describe, for example, what type of information we want to get back, or what type of information we are sending, right? It can also help us describe who are we. Remember, if the request is stateless, how the server knows who is sending the request. And that information can be encoded in the headers. So in the headers, sometimes you will see that we're sending some type of encoded data that has who am I for the server, right? And we will see how that works later. So it's basically metadata about the request. And we have a payload. And the payload is most of these methods, like post, patch, and put, require a payload. Not necessarily, but most of the time they require a payload. And the payload is essentially the data that the client is sending to the server. So data the client is sending to the server. Okay? Now, if you think about it, the get request doesn't require a payload because it doesn't make sense to send data to the server if what I want to do is just get data, right? I'm not sending anything. I'm just getting data back from the server. So post requests, they usually get a payload. Patch requests, you also get a payload. Put requests also get a payload. Now delete, you could, but it's not always not necessary because in the put delete, depending on the resource, that's information enough to identify what resource you want to delete. So it's not necessary to send a payload on delete. Okay? So that's what a request is. Of course, we already know the server, right? Okay? So let me put an example of a request. And you can try locally if you want. And I have one URL here. It's a little bit long, but I will share it with you. I will share it with you on Slack. Let me see if I have the Slack. Give me 1 second. How can I share this via Slack? So this request, okay, this request is for a chat app. Right? Actually, this is the code for the app. I didn't write this code. I just asked ChatGPT to create a chat app using Flask, and this is the code that it came out, and it works. And I'm running it inside code spaces, and I'm going to run the app, right? Now, this is the request that I'm making, and you see in that request, now we can identify all these request properties in the inspection area. So you can go to network, and you will see there, for every request, we can see the headers. So we have the URL, right? We have the request method. Actually, that was the name of this method. And we have the headers. So you see all the headers over there. We don't have a payload here, but you see the headers because this is a GET request. So we have a GET request. We have the URL. The URI is the path. So it's the section at the end of the URL. So a URL has this structure. So this is the protocol. Then it comes the server, colon, the port, and then it comes the URI. So in this case, I don't know, messages, or the path, right? So in this section here, this is the protocol. This is the server, or domain. This is the port. It's not always visible. By default, it's 80 or 443, if I remember correctly. And last is the path name or the URI, right? So this is what we call URI or path name. This is what we call domain. And this is what we call protocol. Now, protocol is, most of the times, will always be HTTPS. That's the secure version of HTTP. That means that if you're not seeing HTTPS in a website, just close it because that's insecure. And your websites should always have HTTPS. By default, the cloud providers that we use provide that out of the box, so we don't have to worry about that. This is the domain. This is the port, not always necessary, and the path. So for the URL that I have here, in this URL, you can see that we have the protocol here. We have the domain with the subdomain here. Right, all this. And then we have the path. Okay? Now, in this case, we're making a GET request. So we have the URL, we have the URI, we have the method GET request, we have a bunch of headers that we don't care about, and we don't have a payload for this type of request. Now, if we want to send a request, right, that is going to change some data, then we need to send, instead of a GET request, we need to send a POST request, and then in the payload, we have to send certain information, okay, for our application to work. Now, this is the request, but what about the response, right? Because, again, for every request, you can expect a response. So response is also, the response will also have some data, some properties. And the first one that we care about is the status. So this status basically will indicate what's the response from the server, right? Now statuses, is basically a number. And these numbers are divided in 5 categories. they are all numbers in the hundreds. So 100, 200s, 300s, and 400, 400s and 500s, right? There is not 600 status. That doesn't exist. It's only 1, 2, 3, 4, or 5. And for each one of these, by the way, 1, I don't know what it is. I never used it before. 200 means success. And there are variants of what a success looks like. For example, 200 means everything is okay. You can expect a response. 201 means created. So you're sending a post request, and I want to indicate somehow that a record was created in the database. I can send a 201 request, 201 response. So that means that the client can say, okay, 201, that means the record was created. 204 means whatever you send, whatever request you send is correct, but I'm not sending a response back, so there is no response, except that it's successful. You can check the documentation about that. 300s are ready-debts. They're usually not for APIs. It's really hard to see an API returning a 300 status. They are used mostly for websites. So when you go to a website and the website redirects to a different page, that's actually a 300 response. This is pretty common one. For example, when you do, by the way, CURL is a command line interface application or program to send requests, right? And I will send a request here for this website, google.com. The -i means show me the response. So I send a request to google.com, and notice that the response was 301. 301 means redirecting to what location? To this location. So you see, when I put google.com, he's automatically redirecting me to 3w google.com. And you can see this working in the browser. If you open this in your browser, you see that the browser will automatically redirect to 3w. The first response from the server is, redirect to 3w google.com, right? So that's what a 301 response means. It's just a redirect. Now, 400 means the information that you send as the client has some errors. So the client request has errors. Okay, and there are several types of errors here. I think 401 and 403 mean authentication or authorization errors. 404, and you probably know this, you've probably seen this before, right? Which one is 404? Not found, exactly. Not found. Now you know why it's a 404. It's because it's a client error. So the client is trying to access a resource in the server that doesn't exist. Who's making the error? The server or the client? The client, because it's trying to access something that doesn't exist. 404, 400 is the request is incorrect. So sometimes you are sending, for example, you capture some data, but you're sending that data to the server, but the server is expecting more data or the data in a different format. So your request, even is to the right URL, to the right method, it doesn't have the whole data that the server needs. So the server can respond with a 400 error. That means that there is an error in the request. So you can see in the documentation how many of these are. And 500 usually means server error. And this is kind of like the worst type of error that your application can throw, because that basically means that you are making an error, right? You as the company, as the developer of this application. The worst one is 500. So 500 means fatal, and essentially is fatal. The application, your server basically shut down and restarted again, right? It's recovering from the error. So 500 means a coding error. That's what 500 means. of course, it's not a good look if you have enough. Like, you wouldn't see normally Facebook or I don't know Instagram making 500 errors, right? The only time they send 500 errors is when they are down, because when you're trying to make requests and the requests are not going through, right? But there are a bunch of things like Y12. I think this is timeout. Not sure, but you can check the documentation. That's the other thing. Requests are not forever, right? When you make a request, you are expecting the response to return in a certain time. So when you're making the request, the client can say, okay, I am expecting a timeout of 1 minute. So I will wait for 1 minute until I get a response. If I don't get a response, I would assume that it's a timeout, right? Or the server can basically take so much time that will automatically send a timeout, right? So there is 2 timeouts. What I'm saying is that there are 2 timeouts. One is that the one that the client sets for the client can set a timeout, but also the server can have a timeout. So some servers have very long timeouts, like 10 minutes. But your client can say, okay, my application depends on one timeout of 30 seconds. If it takes more than 30 seconds, just stop this request, okay? So that's the status. Again, one of these 4 type of status. Now, the other thing that we get in the response is the headers. So we can get headers back. Of course, the headers, as you know, is metadata about the response. In this metadata, it can come the type of data that I'm getting back, right? So if I'm getting back JSON, right, like a JavaScript object, I would get a header saying the content type is JSON, right? Or if I'm getting some type of information, like usually we don't respond, we don't put the response in the metadata. For that we have a payload. Okay? And that's what we need from the response. We have the status, we have the headers, and we have a payload. Okay? So for example, if we're making a GET request, that GET request will have a payload, right? Because all the response will come in that payload. So let's check that same message request. So I will make a request to this URL. Of course. Still on. Let me see. Oh yeah, still on. Okay. So you see, these are the headers of the response, right? I'm making a response to this. I'm making a response to this server, and you see that the response status is 200. So that means successful. And you see all the things that come after are the headers. And you see one of the headers says content type, application JSON. That means that the response is in JSON format. And you can see some other metadata there, like for example, one is important, oh, I don't know, expires, cache control, content length. So content length is how much data I'm getting back, 3 bytes. That's essentially an empty array, I think. Yeah, an empty array, 3 bytes, okay? Now let's make a request to send some data. Okay, so this request, oops. Okay, so in this request, so I'm sending what? A post request. the header -h means header. I'm sending a header content type application JSON. That means that I'm sending JSON. And -d means the data, the payload that I'm sending, right? So in that payload, I'm sending an object that has user, Alice, message, hello world. Remember, this is the backend of a chat application. And the point is to use this backend later in your project, right? Well, in today's class, you will basically create your own chat and you will connect to my server, right? So if you send a message, everybody will see it, right? So the point is that everybody sends a message to that chat app. Don't do it manually, just try to do it via your app. So I'm sending a message here. And nice, it's not working. What did I do wrong? Oh, I'm sending it to the wrong. No, I'm sending to the right thing. Okay. Now let's see what are the messages now. Now we have a message. Okay, cool. So questions before I move on to. Okay, questions for APIs. So this is how APIs work at a high level, right? You have a client, you have a server. Every request have to have some data, and when you send it, you can expect this data from the request, right? We can expect a status, headers, and a payload. Okay, that's how APIs work in a nutshell. Of course, there are other things like authentication, authorization, but those are headers. We will see that later. But essentially, this is how API works. Like this is how all or most websites work today. Like when you're making a request to any website, basically this is what you're getting. And actually, you can see it in the network tab. Like for example, this is 4Geek's website, right, or platform. You can open the network tab, and the network tab will be your friend today. You can see what's happening in the network tab. And let's say here, let's try to do or perform some operation here. Oof, that's a lot. So let's see, what is subtask? Okay, for example, this is a request. You see, this subtask request. This is the URL. This is the method. The response was okay, and I can see the response is basically an empty array. And you can see the headers on the response. You can see the headers of the request. So everything is listed there, right, in the network tab. You can just go to the network tab and see what your application is sending and what your application is receiving as well, right? Everything is there. Questions before I move on to the next topic? So this is how all platforms work, right? This is regardless of JavaScript. I'm not talking about JavaScript yet, okay? So if you're working, like, for example, this backend is built with Python, and notice that I'm just consuming it from a command line interface. By the way, there's several apps that you can install that help you connect to APIs, like Postman. You have one called Postman. There's other one called Insomnia. Pulse. There's also VS Code plugins or extensions, right, that allow you to send requests. So you can use any of these to manually, but these are manually send requests. Okay. Of course, we don't want to manually send requests. We want our application to send that request, right? And what our application uses is JavaScript. So we should see a way in JavaScript to make a request, send it to a server, and get the response. Okay? And for that, we have a function in JavaScript called fetch. And all browsers include the fetch function. All browsers include the fetch function. Probably not older versions of Internet Explorer, but most of them use, like modern browsers use fetch. So that means that we can use fetch. Now, fetch is a function in JavaScript that takes several parameters, and I think the first parameter is the URL. So where are we sending the request? And the second parameter are options. And these options are the request options, or the request properties. So let's call it request properties. So in the request properties is essentially an object with all the possible properties that we can use. For example, if we want to make a get request for getting all the messages, we can send a request to this URL. Now, by default, fetch uses get. So that means that we only need the URL. So this is a get request. So when we use fetch and we only specify the URL that we want to send the request, that's a get request. Okay? Now, if we want to send a request to send a message, in this case, I need to pass the method as post. We need to specify the headers. The header is an object, so content type, application JSON. And we need to pass a body. By the way, body and payload are essentially the same. So in the fetch function, we call it a body. Now the body is the data that we want to send. The problem with the body is that it has to be encoded as a string. So if we have an object, remember here we will send in this information as an object, we can pass it exactly like this object, you see? And that's it. Oh, wait, we're missing curly bracket and the object. Because this is the first parameter, the URL, and the second parameter is the object with all these properties. Right? So the first request, the first fetch, is for getting all the messages, and the second one is something that I will create to send a new message. So I'm sending that message to this URL. Notice that the URL is the same because it's the server and the path on the URI, right? Then I have to specify the method, in this case a post request. I need to specify the headers because I'm sending JSON, so I have to tell the server I'm sending JSON. That's what this content type application JSON means, is that I'm sending JSON, right? So the server can read that. And this is the data that I'm sending. And notice that this is JSON, whatever I have inside. Now, this is not a common way to encode this because remember, in JavaScript, what we usually have are objects, right? So user, Alice, and the message is hello world, right? So instead of encoding it like this, there is a function in JavaScript that you can use to codify that object into a string, and that function is JSON stringify. So message. So I'm going to stringify that variable message, and I will send it to the server. Okay? So this is an example of how to create a GET request and a POST request, okay, using the fetch function. Questions about fetch? Of course.
Is this in the, which file is this in the logs.json or JSON? What
No, I'm just making an example. I'm not saying that this should go in any file yet.
Oh.
I'm not talking about. Now, this is a function, right? So we should expect a response for this function. So response, right? Because if we're making a request, we should get the response, and we will get the response assigned to this. Let's call response 1 and response 2 here. So they're different variables. Now, and this is where things get a little bit tricky, is because APIs work in an asynchronous fashion, right? It's not instantaneously, not yet. So when you make a request, that request can take 1 second or 10 or 100 milliseconds, but it can also take a minute to get the response, right? So this fetch function is an asynchronous function, and we will learn the difference between a synchronous function and an asynchronous function in a minute. So, but again, we are getting the response from that fetch request. Okay, questions? No? Okay, we're going to use fetch in our projects. So that's something that we're going to do today. And these are the one of the two ways to do it. Just with the URL to get to make a GET request. By the way, if you specify here, right? You can say, okay, the method is get. This is the same, right? Because it's still a GET request. But the thing is that GET request is the default, so I don't need to put it. It will just be automatically a GET request if I don't specify, right? Cool. Okay, so what's the difference between an asynchronous function and a synchronous function? Because fetch is an asynchronous function. So asynchronous, okay, we good? Okay, so asynchronous function. First of all, what is a synchronous function? Like, for example, if we have this function sum of a and b, and this function returns a plus b, right? So we have this function. When we call this function, the value is calculated, the function is executed and evaluated immediately, right? That means that if I have a console log here, right? Yes? Oh, I thought you were asking a question. So if I have remember the instructions are executed one after the other, right? Now that means that this instruction will be executed and then the next will be executed. But this function gets evaluated immediately. So I will call the function will do the calculation, and then it will return the value, and then I will go to the next instruction. So C, in this case, will be 30. Okay? That's clear. It's like every instruction gets executed one after the other. Those are synchronous functions. Now, the thing with asynchronous functions are, let's say we are making an async sum, and I will not put what this function has, but when we make an asynchronous function, every instruction still executing one after the other. The problem is that the response of this function is no longer the value. It's something that we call a promise. And a promise is an object in JavaScript that indicates a future value, right? So that means that right after I call the function will return immediately because the next instruction will be executed, but the value is not there yet. So C will not be the value, the sum. C will be a promise of a future value. And that's what fetch returns. Fetch returns a promise. So instead of response, it's actually responding with a promise of the response. Actually, it should be response promise. Okay, so that means that the future will be, the value will be in the future, not now, because I don't know when the server is going to respond. Okay, so that's what fetch is doing. And actually, we can see how that works. I think we can run it in GSBin. So we can call this. Let's do this. Do you see it there? Okay, I would console log response promise 1. Actually, response promise. See, it's responding a promise. Now, what is a promise? Sorry, a promise, again, is an object that has the future value, right? It's a future value. Now, a promise has only 3 states. A promise has a pending state, right? When we create the promise in a fetch is when we make the request is in a pending state. That means that the server hasn't responded yet. And it also has a resolve and a reject. And it can only go from pending to resolve or from pending to reject. And once it's resolved or rejected, it will stay resolved or rejected. So when you're making a request and the server is taking some time, my promise is in pending state. As soon as the server responds, then it will be resolved. And then it will have internally the data. That data in this case will be the response, right? The status, the payload, everything. And if it's rejected, then it will also have some data. In this case, the error, right? Let's say my Wi-Fi get disconnected and then the request failed. That's a rejected state because it cannot complete the request. So that's what a promise essentially is, right? Now, promises are really hard to work in code. Because the thing with promises is that if you want to know when the promise is resolved or rejects, you have to use something like this. You have to use the promise then. So every promise has a function called then, and then you can have some data, and that data is essentially the response of the. And if I console log this, you will see the whole response there. I think I know why. Wait, is it working? Yeah. Fetch. Oh, if it fails, I have the try. Oh no, the catch. Error. Let's see, we have an error. And we don't have any of those. Oh, we have an error actually. What is the error? Failed to fetch. Huh. probably because I'm in a. It shouldn't work. It should not work from this app, right? This I'm trying to call it from another. I mean, it shouldn't supposed to work. But again, you see that promises are really hard to work because now you have to use this then and catch. And back in the day when this was created, when promises were added to JavaScript, the problem is that when you have a promise and that promise have another function that also returns a promise and then a promise of a promise, because everything is asynchronous in real life, right? Then you will have like a then. It was like a block of thens right there. And it was really hard to work with that, right? And then people started complaining. Developers say, well, this is not a good way to create an app. And with time, lucky for us, JavaScript added this, async-await. And you seen me using this before, probably. And async-await is a way to decorate your functions to indicate that some of the code that will be inside is asynchronous. So we can make functions wait for the response before moving on to the next step, right? So this code that we are calling like this, instead of responding for a promise, we can put the word await in front of the function call, and in this, instead of be a promise, will be the actual response, right? And this is nicer because now when we are making a request, we can pause our execution right there until the response comes back from the server, and then we can continue the execution, right? So in this example, we can do await, right? So it will await for the response or await for the promise to be resolved, and then it will continue the execution. So basically, your code stops at that point until the response from the server comes back.
You're kind of forcing it to be synchronous.
Yeah, you're forcing it to be synchronous. Yeah, in a way, exactly. But now the limit here is that you can only put await if you are calling that await inside of a function that is async. So let me explain. You cannot put await anywhere. You can only put await inside of a function that is async. So that is marking that function as asynchronous. That means that inside that function, you can await for stuff that is asynchronous, right? So that's the only issue, but honestly, it's not that important because you can see that you can create just like this. You can create a function that is async. You can call whatever function you want inside, and that's it. The other thing is that a lot of the hooks that we use are already expecting asynchronous functions. So that's the other thing, is that most of the time you're expecting an asynchronous functions anyway, so it's not a big deal. But again, we use async-await for that. So we use async-await, and essentially an async-await function, an asynchronous function now will be something like this. Async function, let's say get messages, right? And you can do this, const response fetch from whatever URL. Oh, sorry, no fetch is await. Fetch, right? Now I have the response, but from the response I need the data, and the data comes in a JSON format, so I can have data response dot await response dot JSON, and I can return the data. And that will be my get messages function. Now the point to create it like this is that encapsulates, right, and abstracts the connection to the server in a single function, right? So I'm not littering my application with fetch everywhere. What I'm saying is that if I see that you are putting fetch inside a React component, that's not good, right? You can call a function that handles that, and that function is the one that uses the fetch function. But internally in your component, there should not be a fetch. And you notice that with this, we are basically abstracting the component from where the data is coming from, right? Because the component shouldn't care where the data is coming from. The component is using getMessage. Whatever this getMessage function is doing is fine. In this case, it's using fetch, meaning it's getting the message from the server. You see where I'm going? Make sense? Maybe not now, later. Not now, I know. Okay, but this is a common practice. Okay? So right now you have a getMessage function. This message function is an asynchronous function. It will get you all the messages from the chat API. The same way, if you want to create a function to post a message, you can create a function post message. What are the parameters of this function? If I want to create a function that sends a message, what would be the parameters? No.
A variable and a function. Okay.
What?
The message.
The message, exactly. Message. That's the only parameter I need. What's the message that I want to send? Now, internally of this function, I will say await, fetch, and then I will say, okay, send it to this URL, and then the method will be post, and then the headers, all the things that we need for a post request to work, and the body will be JSON stringify of message. Okay. From my component, from my chat component, when I send the message, I only call in this function, post message, and I'm passing the message. I don't care. From the component's point of view, the component doesn't care how this function is sending the message, right? If we go to the function, we can see that it's sending the message to this URL as a post request, and it's encoded in this way, right? But the React component doesn't care how the message is getting sent, right? The React component cares about a function to give me all the messages and a function to send a message, right? And this is because these functions now are connected to a backend, but before it could be connected to a state, and basically my app works locally, but it doesn't work in a server environment, right? So I can abstract that. Now, the other thing that I can abstract, what server, right? Because right now I can use a variable here to indicate what server, but if I need to change the server, I only have to change one variable, and everywhere I'm using that is already modified, right? So again, I'm trying to add layers so it's easier to maintain my app, okay? And this is one of the ways, create functions for every request that you want to make. So that's the thing that I want to do today, is like create functions for every request your app has. Okay, so if your app has two requests, one for getting the messages and one for sending the message, you have two functions there. If your app has, let's say, a request for, let's say it's a, I don't know, it's a game app, right? Start game, make a move, and give me the status of this play, and give me the scoreboard. For every one of these requests, I have a function. And that's the function I use from React, from my component. Make sense? So encapsulate that behavior in functions. Remember, I told you before, functions is the main thing when you're writing React applications, because every component is a function, every request is a function, everything exactly is encapsulated in a function. Okay? Cool. Questions? Let me stop this here.